Okay, so the average altitude times width, future value of average monthly contribution, times the number of years during which the contributions were made. Well, multiplying an average monthly contribution by the number of years would not give you the total contribution, would it? You would have to multiply 12 times your average monthly contribution to get your average yearly contribution, which would then give you the total. So the total future value could be expressed as, well, let's put it this way, average future value per month times the number of months. With emphasis on using months as the basis for your rate of accumulation, since and for your unit of time as well. It doesn't make good sense to use the number of years and multiply that by the average per month. Okay? Either you would figure out the average per year, and you could do that, just multiply your average per month by 12, and you would get the average future value per year. And that could be multiplied by the number of years then, or express your number of years in terms of months. Okay? Express your time instead of in years, in months. And that would be very easy to do. And we would then get a graph very much like the one you see here. Okay? Where we have our 1,100 per month, our 900 and 750 and so forth per month. And I've just done a ballpark estimate of our areas and our accumulated areas, and those things are very easy to calculate. I think everybody knows how to calculate those. And labeling, of course, our time axis now in months rather than in years. So when we do that, let me draw the graph a little bigger. So we have our average, well, we have our monthly our future value per month goes from 1,100 at 0 years to 900 at 5 years. Well, 5 years is 60 months. So we have time in months now. And then we go down to 750 per month. At 120 months, of course that would be 10 years. 620 per month at 15 years, which is 180 months, and about 500 per month at 240 months. Okay, so our trapezoidal graph might look like this. And now it's clear that the average altitude representing the average future value of a monthly contribution, that would be the average future value per month, multiplied by the number of months. And of course that's what you get when you do average altitude times width, gives you the area, and that represents the total future value. So the total future value here, this isn't an estimate, this is right. I write 60K, $60,000. And then I think this one came out around 49.5 thousand. And then I'm pretty much going ballpark here. So maybe 45,000 and maybe 33,000. Those might be right to the nearest thousand. I shouldn't be off by more than a little bit. Actually, at 45 is probably a little high, just looking at the trend. Probably closer to 42 or 43. So I'm not going to change it. using these numbers that you can easily modify, because you can easily do this very simple arithmetic, our accumulated areas are 60,000, 109,000, 154,000, and 187,000. Now we can compare that with the accurate result that we can get by integration, because of course, the trapezoidal approximation approximates a curve here. So this is, you have a piecewise linear approximation of an actual curve. The area under that piecewise linear approximation represents the total future value, so that if we can figure out what function this approximates, and that is actually very easy to do, we can then determine what the total future value is going to be.